Hello, in this video, we're going to discuss how we implement 360 LiDAR in Unreal Engine 5.7. All right, so let me briefly go over the structure of the LiDAR simulation. For this simulation, I haven't wrote a single line of code. I used AI, specifically Google Gemini. And so let me discuss how we structured this LiDAR and how we ask the Gemini how to write the code. All right. So the first thing is that for this LiDAR, we utilize six cameras in all 360 degrees, as well as top and bottom. So we put the camera such that it covers all six cardinal directions: front, right, back, left, and top and bottom. Then for each camera, we put the depth map. Okay, those are textures, and that's 1024 by 1024. And in each pixel, it captures the depth information. All right, in it's in the VRAM, so it's in the GPU. Then what we do is that we utilize the compute shader on the GPU. We dispatch this compute shader, and it actually goes and samples corresponding UV coordinate value, and then convert that into 3D coordinates, right? And then store that into a long array so that CPU, the code on the CPU can pick that up, all right? So then the C++ codes are basically running on the CPU, and that basically does the orchestration of dispatching the compute shader on the GPU. And when it collects the points of the 3D, and it retrieves those points and use that points for visualization as well as ROS to publication for autonomous navigation and computer vision tasks. And we're going to cover these in the next video. Okay, so this is the structure, and let me briefly show you how I actually build the blueprint. So all this compute shader coding as well as C++ coding as well as blueprint building is all I got the idea from the AI. So I was basically structuring this the general idea of LiDAR simulation, and then the details of these things are all retrieved from the AI. All right, all right. So here, this is our LiDAR model. All right. So as I've said, there are six cameras, 90 degrees of field of view for each one of them, and on each camera, I put six of these textures. Okay, each texture captures the depth information in our channel. Okay, that's why it's all red. All right. Currently, I have that LiDAR, 16 channels, so 16 rings. And then in each ring, I have about 1024 number of beams, and its field of views are -15 to +15. So if I start, you're going to see the green dots here, okay? So if I go over here, so as you can see, the LiDAR is now encapsulated inside of this cube, right? And so as I move, you're gonna see how the beam, the beam changes. All right, I can even rotate it. Since I'm running all this on a GPU, it's extremely fast. Okay, the only thing that takes time here is to visualize these point clouds on a CPU. But in real simulation, you don't have to visualize these point clouds. All you have to do is publish to ROS, so that the ROS actually does the point cloud processing, right? So let me change the configuration. So over here, let's see, I can change, let's change the channel to 32, and let's change the field of view from -45 to +45. Compile this, save it, go over here, run it. All right, as you can see, let me see, as you can see, the points are now, covers a lot. We have more rings, 32 rings here, and then it covers -45 to +45. And so, it covers a lot more areas. And you can turn this, right? You can easily see how these things work in real time. All right. All right. So that's how we built the LiDAR in Unreal Engine 5.7. And let me show you how this thing can be actually mounted on a drone and flies in the town. So here we're gonna attach the drone on. We're gonna fly the drone by attaching the lidar on it, and we're gonna fly through this street and see how it scans. In the next video, we are going to show how we actually transfer these point clouds to ROS2 for computer vision tasks.